This is the 18th video in my series on three-phase power transformers. In this video, we'll be having a look at transformer construction. This is an excerpt from my course entitled Electrical Three-Phase Power Transformer Fundamentals. You can access this and my other courses on my Stan Store at this web address. Transformers are a critical and expensive component of the power system. Due to long lead times for repair and replacement of transformers, a major goal of transformer protection is limiting the damage to the faulted transformer. Some protection functions, such as overexcitation protection and temperature-based protection, may aid this goal by identifying operating conditions that may cause transformer failure. The comprehensive transformer protection provided by multiple function protection relays is appropriate for critical transformers in all applications. The type of protection for the transformer varies depending on the application and importance of the transformers. Transformers are protected primarily against faults and overloads. The type of protection used should minimize the time of disconnection for faults within the transformer and to reduce the risk of catastrophic failure to simplify eventual repairs. Any extended operation of the transformer under abnormal conditions such as faults or overloads compromises the life of a transformer, which means adequate protection should be provided for quicker isolation of the transformer under such conditions. Most transformer failures fall into these categories. Winding failures due to short circuits, turn-to-turn faults, phase-to-phase faults, phase-to-ground faults, and open windings. Core faults, core insulation failures, and shorted laminations. Terminal failures, open leads, loose connections, short circuits. On-load tap changer failures, mechanical, electrical, or short circuit overheating. Abnormal operating conditions, overfluxing, overloading, overvoltage. And external faults, which could lead to overloading. If not detected and isolated from the system, catastrophic results could occur, ending in losses to the utility fleet equipment, not to mention the secondary losses that the client may occur and for the utility in terms of revenue. The construction of a transformer in its basic form consists of two coils, at least one high voltage and one low voltage, linked by mutual inductance, and a laminated steel core. In all transformers that are used commercially, the core is made out of transformer sheet steel laminations assembled to provide a continuous magnetic path with minimum of air gaps. The steel should have high permeability and low hysteresis loss. By effectively laminating the core, the eddy current losses can be reduced. The two coils are insulated from each other and from the steel core. The device will also need some suitable container or tank for the assembled core and windings, and to hold a medium such as oil, which the core and its windings can be insulated and cooled. In order to insulate and bring out the terminals of the windings from the bank, appropriate bushings that are made out of either porcelain or ceramics must be used. Generally, the name associated with the construction of a transformer is dependent upon how the primary and secondary windings are wound around the central laminated steel core. The two most common and basic designs of a transformer construction are the core transformer and the shell transformer. In the core type transformer, the primary and secondary windings are wound outside and surround the core ring. In the shell type transformer, the primary and secondary windings pass inside the steel magnetic circuit, the core, which forms a shell around the windings as shown. In both types of transformer core designs, the magnetic flux linking the primary and secondary windings travel entirely within the core with little or no loss of magnetic flux through the air. This video is part of my Electrical Technical Information series. In this series, I'll be covering essential topics to help you understand electrical systems. Be sure and stay tuned, as I will also from time to time be reviewing electrical products that, in my opinion, are worthy of paying attention to. One of those amazing and versatile products is the 𝐃𝐈𝐒𝐂𝐋𝐀 Delta Pro Ultra, which can be modified to suit any homeowner's needs, operating virtually silent, and when paired with the 𝐃𝐈𝐒𝐂 Smart Home Panel 2 is extremely versatile. The 𝐃𝐈𝐒𝐂 Home Panel 2 ties any and all of your standby power equipment together and will control them efficiently. It will even control your connection to the utility grid to make sure you're only using the least expensive power, switching to your standby power during those expensive time of use rates. In order to view the full range of 𝐃𝐈𝐒𝐂 products, check into this website to browse the full extent of their products. There is no cost or commitment for viewing. Before ending this video, let me repeat the connection to obtain my free copy of the Ultimate Guide to Residential Standby Generators and receive access to all of 𝐃𝐈𝐒𝐂 products. Also, here is the connection to obtain a free copy of my 50-page electrical power crib sheets. And finally, here is a link to all of my electrical courses, which are located in my stand store.